Yes, the title of the talk was the Entity Microservice Trap. You may be doing it wrong. Actually, it should be you're screwed if you're trying this technique. Just a little bit about me if you haven't run across me before. Really, the only interesting stuff is it's kind of on the right side. I'm a technologist. I've been sort of the bleeding edge guy in almost every technology wave since I got started in programming. That means a lot of the things I do, I tend to be one of the first adopters. So if a lot of stuff I'm saying today doesn't make sense to you, it's kind of okay, and maybe another 4 or 5 years before you get around to it. But I have a pretty good track record of guessing correctly. What's really my real job is more associated with this. I'm basically a disruptor. A disruptor is one of the actually official titles of people in organizations now at the C-level. The job of a disruptor is basically to question everything they're doing. It's not a good guy necessarily to have in all their meetings, but you want to be a part of that. So I go into organizations, I do tend to make changes. This was actually my job description at the Daily Mail in London. I was described as the hand grenade being thrown into development. If you can ever get this job title, you should take it because it's a lot of fun. So yeah, I tend to have a lot of radical ideas. At this moment in time, when you get to my age particularly, you sort of reminisce about things. And today in microservices, kind of feeling like about 15 years ago when we were in the beginning ages of Agile. And this sort of comes up that, Agile is largely very productive. I mean, people are doing Agile and talk about this is very productive. This is what basically Jeff Sutherland said at a conference about a year ago. In all his projects, he at least gets a 4 times improvement of that. In projects I've done over the last 15 years, I've got at least that sort of productivity. But then you see a number like this. So this is what a large consulting firm here in the US claims that's what they're seeing in Agile productivity. At best, 13%. What's the difference between the 4X guys, which I seem to do and they're doing, and the 13%, which seems to be, what the average seems to be that they're talking about? And to some degree, it has to do with we're just not doing it right. And I think microservices right now is kind of in this heyday. We're kind of in the early days, and are we going to have the same sort of fall that we sort of had the same fate of Agile? That all of a sudden, the next year or so, we're going to have all these articles in the trade press about these microservice failures. And of course, there's a microservice certification process will come up, and you'll be microservice scrum masters, and all these other things like this will happen. Yeah, we will go through that phase. It's undeniable we're going to do that. Too many people are saying microservices. Too many people are agreeing it's a good idea. It's getting to the point where CTOs or CIOs have to say, I understand microservices to get hired, even though they don't. So we're getting to that point where we're going to do that. So what's going to happen here? And I'm going to sort of rant a bit about some of the problems we're going to run into that I begin to see a little bit of already. And a lot of this goes back to this guy. This is Fred Brooks, Turing Award winner, very early Turing Award winner, author of the Mythical Man Month. He is the guy who basically did a lot of the design of the early 360 operating systems for IBM. And I grew up in IBM myself. I joined IBM in about 1974, worked there for a long time. And his philosophy was basically one we adopted. It says, you get your data structures right, and the code can write itself. Now remember, he's talking about operating systems that are about 60K, which is a whole different world than we live in, but that was kind of the idea behind it. And so we actually worked that way. We'd have our data structures, we'd lay them out. This is all done in assembly language coding, by the way. This is really a dissect, for those that understand what that term is. And then basically, you're right, all the code tended to write itself. And this it's a really important thing. In fact, we tended to put somebody in charge of just that data structure. That was his full-time job as a programmer, was to maintain that data structure. Actually, I just noticed I colored him in brown, which seems to be an appropriate color for the job, because it wasn't a very fun job. And then, of course, all the rest of us would try to write code, and we'd go to this guy and ask him to, can I have another field? He says, well, how are you going to use it? And we'd argue about it, and he'd be very reluctant to make changes. But that was his job. Now, that was 1970s. Roll on to the 1990s. What I see is this. We have this relational database sitting in the middle of the world. And yeah, if you get your relational database structure right, yeah, you can write lots of code around the side, and it makes it really good. But oh my God, there's this person in charge of that database. So by the way, it's two databases now, the reporting database versus the operational, because they're organized differently for different purposes. And yes, there's still that person in charge of this. You know, they have all sorts of new titles, DBAs of some sort, architects, and oh my goodness, you try to get a change to that done, it's like, you know, you're asking for the firstborn child. And for good reason, because once you start tweaking that thing, nasty things can happen. So migration scripts and everything have to be approved. And I've wrestled with this. And by the way, why wasn't Fred Brooks talking about the database back then? Well, in 1970s, SQL was just a concept I studied in university. Nobody could actually really build something so inefficient. It didn't exist. So of course we didn't talk about databases, but you see the picture looks very much similar, and I'm feeling the same sort of thing about that this is holding us back. So you sort of go back to this approach, and I talk about a corollary, because we figured out pretty quickly, and I would say certainly by the 1990s, that Fred Brooks' approach did work. It's true. You get that data structure right, the code writes itself, but there's also a corollary. It says, yeah, but you can't change it without making all the code suspect, without having to go back and retest everything. And back in our day, I mean, 60K of software is not that much, you would think, but we had to use text editing tools even to find references to fields. There wasn't any sort of concept of IDs. Just trying to find this code was very hard. And hence was born out of this the object movement. It says, oh, by the way, let's sort of take that big giant dissect and carve it up into little pieces and give each piece a little piece of code and hide it. They did encapsulation. Interestingly enough, historically, the guy who did data encapsulation, Dave Parnas, actually worked for Fred Brooks at the University of North Carolina. And basically Fred Brooks did admit, yeah, Dave, you got a better idea. My idea really does suck. So you have to do it the right way. So we broke that thing up into objects, and so we kind of broke that dissect up. So that's kind of where we got with that. And by the way, we played lots of tricks back then. You can't believe how clever we got. Of course, you don't want to touch the green stuff, so of course you put new fields at the bottom. But one time we put a variable length field at the bottom. So what we could do then? It's like, oh my goodness, what do you do then? Well, you put fields at the top, negative offsets. Seriously, you can do this in assembly language. It's quite easy. You just go up 4 bytes and look at something else that's going to be there. So all sorts of tricks were pulled just to not touch that middle data. That's how volatile it was. I was at a presentation, actually, at the YOW conference in Perth last year. And these guys stood up and said, oh, by the way, we have this centralized database. We're doing microservices. And we're able to deploy a couple of times a day. And they kept listening. I said, this is fascinating. I wonder how they did this. And they said, oh, yeah, what we do is we can change these as long as we don't touch the database. And I'm like, oh, that kind of eliminates almost all the interesting stuff, doesn't it? But we couldn't touch the database. So, yeah, the same problem is beginning to exist. We recognize that we have the same problem in microservices. Now, there's books out there that how do you attack this thing? How do you sort of build your database so that you haven't got these sort of issues? How do you get around this sort of thing? How do you make this sort of Agile database? And of course, there's an entire book about this, Agile database design. And it sort of talks about, here's the tricks you could do where you don't have to touch the schema so often. And one of the tricks they talk about is this one. I've used this trick myself, sort of this flexible schema sort of concept. And the idea is instead of sort of defining all your fields and columns, you kind of define yourself a whole other table that has data in it. And you have a column for integers, a column for floats, a column for strings, et cetera, et cetera. And you kind of tag which one it is, and basically you have to point to a lot of these. So these guys are just point to each other with some sort of join table, saying, oh yeah, my data has these fields, and I want to add one in. It's not a big deal. Just kind of just throw it add in there. Kind of cheating, kind of makes the queries run a little strange, but it does survive changes. But that's the sort of technique we have to get around in order to allow ourselves to run at a pace that's more than one release every 4 or 5 months. So along comes other solutions. Let's say, okay, let's try some of these non-SQL stuff. So some of the non-SQL stuff, no SQL stuff, arises out of this problem of having to understand that data so much. And this whole industry has grown up. It's very powerful at this point. I mean, there's a lot of interesting databases out there. And if you look at some of the large companies, especially in Silicon Valley, you find out that they've abandoned SQL for the things that don't seem appropriate for it. Yeah, they probably still do payroll with their SQL, but they're not doing all the other stuff with it. They found it not to be the right sort of data structure, and they've gone other places. So you have this whole hierarchy of structures from simple key value stores all the way through graph databases. And they have very, very appropriate business problems they're trying to solve that are not payroll. But they sort of have these things in common. They're really all about trying to get away from locking yourselves into a particular schema format. You're trying to, when you have that schema format, you're basically trying to predict the future. And back when storage was really, really rare, and we were trying to really push as much stuff into as little fewer bytes as possible, it made sense to sort of spend some time, think about it, let's get the design perfect, let's optimize ourselves to minimize our byte footprint. But when you've eliminated the need for that storage to be so scarce, then some of these other solutions make a lot more sense. And we want to get away from trying to predict the future. That says, I need this field. This field will be useful for the next 5 years. Or if somebody's going to need this in 3 years from now, I better put it in. You'll get a lot of arguments from that group that says, don't put it in now. When we need it, we'll put it in because we may not need it because it takes up space. Space is very valuable. We've got to save our space. And unfortunately, most of our DBAs and DB architects are still thinking that way. It's about, I got to make sure I optimize my space. I got to make sure I cram as much as possible into a single bit. So now you move on to the conclusion that says, this is very nice, and he has some schemes to do this, but fundamentally, in order to get around this problem, you've got to break the database apart. We've got to do the same thing we did with the object movement, going into the Fred Brooks model and tearing the data apart, putting it into little pieces. You want to do the same thing with the database. You've got to kill that central database. Even if it may be a large graph database, you still may want to tear it apart. So you get the concept that says, okay, let's break this guy apart. And what I really want to do is, get rid of it and put little databases with each service. Basically, rebuild the concept of an object model and its encapsulation into this new world. Now, this is the right approach to take. So you got to coordinate among all these services in some way. So you probably have a couple of choices. If you're using synchronous architecture, very much like some things that Netflix need, then of course you got to be able to have the services find each other so they can communicate with each other. You have some services like that. I'm a particular fan of asynchronous architectures. In this case, we put an event bus in place. I'll talk a bit more about event buses in a little while. But we use sort of an event bus and let people communicate indirectly through the event bus. But you sort of got to scratch your head and say, okay, why am I tearing everything down? What am I trying to get out of this? I mean, what's the goal behind this whole why am I doing microservices again? Because it's getting really ugly. And the really answer is you're trying to get some wicked speed increase. And by speed, I don't mean the execution time of the code. I mean from the time I have a requirement till I try to get out the door. That's the holy grail these days. Your competitors are getting faster and faster about trying ideas out. So one of the things I guide myself around is, in order to get speed, you've got to reduce the coupling. You want to make sure the pieces of your code are as much as possible completely separated from each other. And for that, I go back to, I like to look at a presentation by Jim Weirich, the late Jim Weirich, unfortunately. We lost him a couple of years ago. And he had a presentation he talked about Connascence. He called it almost it was this global unified theory of software. You read Connascence is kind of a really fancy word. In fact, it may not even be your dictionary. It certainly doesn't translate to other languages. But read that as almost coupling, and levels of coupling. And he basically sort of said that in his presentation that there's various levels of coupling necessary. And there's almost some sort of hierarchy of these couplings, that there's stronger and weaker versions of that. And he has this rule of locality. The closer things are physically, the more you can couple them together. But if you really want them apart, and that's what I'm really after, you want some very, very weak forms of coupling at best. That's, by the way, the Euro reference to his presentation. I definitely encourage you to go listen to it because it's a fascinating presentation. It also does make you feel kind of stupid. I mean, there's some smart people in the world, and he definitely was one of them. He talks about the various degrees of connascence, sort of in the increasingly things. Name connascence, where the name of something here has to agree with that. So if I'm calling a function, I have to know its name in order to get to compile. Let's see. Position, ordering of parameters is very important. So if you have an ordering parameter thing, it's a positional connascence. It's a bit of stronger. Meaning, when I say one, I mean red. When you receive one, you better believe it means red. Very indirect sort of relationship. Another kind of a strong coupling you got to be very careful of, on down through these others. So he goes through all those and talks about those. And I guide a lot of my designs based upon that information. So we need to move to some sort of way to break this database up. And your first impression is going to be, let's break it up along entity lines. It's kind of the natural way we think about it. We already got tables named along these lines. And it would be the first approach. It's not really a surprising approach at that level. And it's not surprising we struggle a little bit, mostly because microservices involves other things. We're trying to do aggressive deployments, and that's going to have its own set of issues. We got to reorganize ourselves differently. There's DevOps moving in and out. There's a lot of other things going on in parallel to microservices that create a lot of noise around this. So you're going to have some struggles moving even to entity microservices. But what you're really trying to build is, you started by saying, okay, well, let me break it up along the database lines, because I'm really good at database design. I've been doing this for 20, 30 years. We know how to break up things by database lines. So we'll have the entities out there. We'll group them together. If that's a sort of your relational model, we just kind of break it up along those lines. Natural way of thinking. In fact, the first step I see many, many organizations take. And it's kind of driven by a couple of other reinforcing things. There's Conway's law that says you should break up things along organizational boundaries, which are kind of align up very nicely with that. So yeah, of course, entity services make sense. I own various bank accounts. You own client relationships. Well, you own that service. I own this service. And then you got the REST guys jumping in. And of course, the REST APIs in its pure form is basically just database access language. Here's how you do an update. Here's how you do an insert. Here's how you do a delete. A various set of verbs doing that. So you got REST sitting there saying, oh yeah, your service should be like a database, and you should have CRUD transactions against it through these RESTful interfaces. In fact, here's a quote from one of their services. They're very commonly used to create APIs for web-based applications. I mean, that's the guidance we're getting. So you convert your monolith to entity-based services. That's the first thing you want to do. So take those database designs and basically build yourself a little service around each one of those. And then you get to ask the question, okay, where are you going to put the business logic? How are you going to glue these things together? Where do you put that? Do you kind of create a new service as sort of the moderator or the orchestration engine that does this work? That pretty much will turn into some sort of God service pretty quickly with massive methods and all of the business logic there. Or do you kind of stuff it into one of the other places? Rails is basically a big fan of stuffing the logic back under the database elements, so maybe you should do it like Rails does it. And so you run across these issues. Where are you going to put this business logic? And it's really not a good answer, because all these answers lead to big tar balls of a new nature. And there are even more issues coming up. One that comes around performance. I mean, if these used to be database tables, and you really want performance, do you really want to go to every record of the per client, pull them in, pull every record of the orders, pull those in, figure out where they match up to create the join? I mean, the whole idea of joins and databases is trying to minimize the interaction with that. Yet if you sort of put these things in different databases, you're going to be stuck with across the network and RESTful interfaces pulling this stuff in. And yeah, you may have a 30 gigabit backplane on your machine, but you're still going to drown yourself in how many bytes you bring across. So if you try to do joins, and what do you do with a stored procedure? There's really efficient things that run these instanting algorithms and give you back one or two records. You're going to be pulling all the raw data in and trying to make that thing. So it's not going to work. And of course, cap theorem comes in as well. So these are problems you're going to run into. In fact, this is what clients are starting to run into when they start going this way. In fact, this is where SOA ran into a lot of issues when they started trying to separate out along the lines of big databases over here, and I own the customer database, you own the orders, and we'll sort of try to figure out how we're going to communicate with each other. They ran across the same issue. So let me go back and sort of say, let's talk about what problem you're really trying to solve. You're going to microservices to solve particular problems. First thing I sort of ask my clients as I get into this is sort of what type of problems you're trying to solve, and I use the Cynefin Framework from Dave Snowden. Dave basically says the world's divided into 4 types of problems. It classifies simple problems as having very straightforward cause-and-effect relationships. Not very interesting for us. Complicated problems, is a cause-and-effect relationship. It's a bit convoluted. It'd be like accounting rules and stuff like that, but there are rules associated with it. There are experts that can do this for you. But he doesn't stop there. He says there are also another set of problems he's seeing called complex and chaotic. And complex problems there is no cause and effect relationship. Just because something happened doesn't mean you can figure out why. Yes, for this particular instances, I can figure out exactly why it happened, but it doesn't help me predict the future. Your financial markets, Google advertising, all your recommendation engines, these are sort of complex problems. Yet these are the problems we're being asked to solve a lot today, sometimes with SQL databases. So it turns out in this sort of structure, consistency is very important in a rule-based thing. If I don't want my bank account to have maybe you got $5, maybe you haven't got $5. Maybe the deposit made it, maybe it didn't make it. This is not a fuzzy problem. So it's a complicated problem, but you need consistency. But in complex problems, it is fuzzy. Should I loan you money? I don't know, maybe. I mean, I can have 1,000 different answers to questions like that, and I'm still not sure I should loan you money or not. There's still some risk associated with that. So it turns out these are fuzzy problems. And because they're fuzzy, I can have eventual consistency with my data. I'm not stuck with having to have perfect information. And yet a lot of your organizations are about, I have to have perfect entities. They have to be perfectly synchronized. Otherwise, the system won't work. Actually, for complex systems, I don't need that. It's an unnecessary restriction. You need to kill that off. If you go back to people that are beginning to do microservices, some of the early success stories that are being talked about, a lot of them have to do with taking some gigantic Rails applications that startups have built up, and all of a sudden they're kind of like dying, and not dying very well. And what they wind up doing is they wind up having to go into those applications and convert to microservices. But the first step in that process is usually just taking the database and breaking it apart. Don't even worry about the services yet. Let's just get this gigantic database into small pieces so I can wrestle with it better. And then I can start building behavior-oriented services around those things. And the key is behavior-oriented services, not data-oriented services. Whereas I want a service to actually do something. Ask it a question, it gives you some conclusion it's drawn based upon doing some analysis. It's not a conclusion to say, I need to know how old you are. You're going to tell me. That's not a service. It's like, what are you going to do with that age? What are you really curious about? Are you think I'm going to die too soon? Okay, ask me that question. That's the sort of thing you want to change to behavior-oriented services. And so you'll wind up with several services with somewhat similar data, and that's okay. And the guys have been doing this, and in fact, there's good presentations about this. I know that Chad Fowler at Six Wonderkinder talked about this 2 years ago in Berlin. That presentation is online about how they took his gigantic Rails application and tore it down. The Guild Group has a very similar story of how they did their site for fashion sales. Halo did this for their taxi service in London and Ireland. And they all did it the same way. They tore the database apart and took it apart. So this is the approach you've got to be thinking about how you're doing. My favorite approach to this, and I talk about this quite a bit, is the concept of event bus. One of the things I'm seeing happening in Silicon Valley extensively is they're getting rid of the operational SQL database. That's not the core of their world anymore. The core of their world is a persistent event bus. The idea that things are happening and they're going to put in an event. They're not trying to optimize the storage. They're not trying to filter anything. They're putting all the raw data on the event bus because data is cheap. Now they can go back and analyze and reanalyze it to their heart's content. And that's kind of how they build their systems. So they get rid of this guy out of the picture, throw that guy away, and they put in an event bus. Now they probably still have the reporting store because frankly, reports and SQL work really well together. And reports are things that you want to make some business decisions based on. So we're still pushing information out to the data warehouses we always have, but the event bus becomes real. And these little databases are basically sort of cached information or whatever information that little service needs, but just all it needs. I talk about some examples of this when I talk about microservices, where we kind of have lots of little databases, and in fact, we don't necessarily choose the same database technologies. Each service needs can use what it has to need. So in my scenario, I'd like to talk about this advertising. It's called an offer engine. This is a case where you basically you want to put more advertising on a site. Somebody comes to your site, you get a chance to sell them more. The McKinsey guys call this share of wallet. Now, how do you get a little more money out of a customer that's already showing up at your door? And so, in theory, behind this, you would be, somebody shows up at my website, I put myself sort of an event bus in place, put a couple of services, and so basically the guy will come down and say, you know, do you have some ads for me? And the little yellow guys will answer, yeah, I got some ads, and they'll compete for the business. It's kind of a fuzzy problem. What ad should I show to get more of your money? And I may have other little microservices running there, providing additional information about membership in my frequent renter program or market segmentation. But if you sort of tear into these little services and look how they look, you'll see this little service right here is actually consists of something I would run in 4 containers. There's a little microservice or a little container running there that says, oh, by the way, I need some advertising. Puts a message on the bus. There's another piece of code in there saying, listening for the answers. It says, here's some answers coming back from various services, bidding for your attention. And I'm going to adjudicate between those. But all I'm going to do is basically stick those in a little Redis database, cache them. And after 300 milliseconds, because I'm running IE6 or some other browser like that, I'm going to basically look in the Redis database, pick out the best answers I found so far, and push them back to the user. A microservice. But it has its own little database. It's a little Redis database. It's particularly cached. I don't have to worry about backing it up. If I'll lose it, fine, I'll lose it. I just rebuild it because it's just a cache. But it's tuned very nicely for this environment. Similarly, the membership service, this is where if I want to find out whether my user is actually a member of my frequent renter programs. Because if it turns out you're a member of my program, it turns out I want to give you a slightly better deal. If I give you a better deal, you're more likely to stay with me. It's very cheaper to hold on to you than try to win you back from the competitor. So I want to give you a little better deal. But of course, you open that little service up, and you find out there's 2 or 3 pieces of code running in there. Again, in this case, 3 containers. I got one little service there looking for somebody to pop a message on there saying I have a need for an advertising and who it is. If I can look up the person and find their name, I want to put a message on the bus saying, oh, by the way, Sally is a platinum. We want to make sure we try to rent to her. And it's pulling this information out of a key value store because it's basically just user ID, status. User ID, status. That's all it is. Now, that table gets built every night. We go to the data warehouse, we pull up the latest status from everybody, we put it into a little key value store, a little ETL process. Runs as a cron job in the little microservice. Again, database. If I tweak that database, I will definitely have to tweak the blue code. But I don't have to tweak the yellow code or the green code just because I touched that one. And again, if this database is out of date, fine. So maybe I didn't run last night, fine. So I'm working with day-old data. I can live with that for that problem. Eventual consistency is fine. So I talk about this sort of style of programming in a workshop I ran. We ran it yesterday. I think some of my students are here today. And I found it interesting because I've talked about this sort of style of programming for a while, and people nod their heads. And then I put an animation together watching all this stuff work really well, and people said, wow, now I really understand it. And then I started running the workshop, and people said, well, okay, now I really, really understand it, because it works out very strange. It's, again, a Workday workshop. Done quite a few of these, and I'll be doing quite a few more late in the near future. But almost to a person, a lot of these people in the class say, yeah, my company's doing microservices. And almost to a person, when they walk out of the class, they say, wow, we're not doing that. We're doing entity-based something. We're doing something else, and we're beginning to have trouble. That's why I'm here at the class, because we think we'd be doing it wrong. And kind of the right answer is, yeah, you should be suspicious of what you're doing. Because basically, it's not like doing it like the workshop is doing it. So that's kind of my rant for the day. Microservices are very cool. I think it's a very powerful way to work. It's extremely powerful for solving the complex problems, which are in fact sort of the problems that, frankly, you make a lot of money at. We solved complex problems at a company I worked in London, Ford Group. They were doing internet advertising. We made £50 million with 50 people that year. So solving these complex problems and solving them effectively and solving them very quickly was a competitive advantage for us. And these are the sort of techniques we were using. So it works very well. So for solving complex problems, you've got to rethink it. If you're just doing microservices because it's cool, yeah, don't start, please. We don't want to hear about the failures. If you're trying to do entity-based microservices, you're going to hit a wall. I would prefer you stop now and rethink it. But good luck with that.
Thanks.
Thank you.